It is my pleasure to introduce the keynote speaker for today, who is somewhere around here. Toufi Saliba, who is actually a serial technopreneur, my colleague, co-author of Toda Protocol, and the co-founder as well as CEO of Toda Network. Please give a warm welcome.
Thanks, Chantal. Today I will be going through some use cases that can utilize AI in a setting where we call it the Crypto-HBGA, incentivizing a human to contribute to the machine learning that can then become AI. So it starts with human intelligence, hybrid intelligence, and artificial intelligence. Another use case I will be going through is combating AI using cryptography and not AI. And this is specifically DeepFake. How many of you are familiar with DeepFake? Have heard of DeepFake? Cool. I will be covering what DeepFake is. And the third use case is something that recently, which is just yesterday, was published at the UN by the Interpol based on recommendations that I've made to the Interpol last July. And it's the ability to trace criminals without invading privacy of the innocents to a certain extent. I mean, currently the invasion is much larger than what it could be. So I'll be going through those use cases, each and every one of them using cryptography to the best extent. And many of you have heard of that is called a blockchain. I will not necessarily be talking about a specific blockchain that can enable this kind of stuff, but I can tell you with certainty that what you see out there cannot enable this stuff as is. Some implementations in the future could, and some implementations that they already exist in some areas, they're already in production, they can facilitate this stuff. So those are the three. I usually leave the last slide of who I am and what do I do. Those organizations are only some of the organizations that I'm involved in on a daily basis. So I have a problem of receiving, on average, about 5,000 messages addressed to me personally. So it's like, hello Toufi, we've met at this place, or hello Toufi, we'll continue the conversation. And there's a solution to that as well, by the way, and one of the companies working on that. I also am an invited speaker at the World Internet Conference in China, despite what many people think that the Chinese, they hate my perspective on certain things. They actually invite me to speak on a lot of events. They're open to different point of view than the normal thing that is actually happening. Today, Financial Services Roundtable and BPI, that became BPI, which is the Bank Policy Institute, is the #1 aggregator of banks as an audience to them. Almost every North American bank, or every American bank, CEO is a member of that. So when folks see me in underground Bitcoin events and crypto and so on and so forth, they would think that it's impossible for that same person to be speaking to group CEOs of banks, because this is against that. But in reality, all of these combined, they have one thing in common, which is a mission of mine that I'm working towards, that I strongly believe each and every one of you believe in. And it's efficiency. So efficiency is the one common thing between every single Homo sapien. If you introduce something that can potentially be 20% more efficient than the previous system, you will fail. Nobody wants to go through the effort to just 20% reduction. But if you have something that can be 99.99% more efficient, it will not only replace, it will disrupt and it will be revolutionary. That's what I'm here or stand for. So when I say revolutionary, I don't mean coup d'etat. Again, some people, they might think that here's a revolutionary is here to disrupt, I was last minute refused by certain folks in, I don't know what name, where, but somewhere in the Middle East, because they said, that's the revolutionary guy coming to speak here. We don't want another revolution in Arabia or whatnot. Well, the revolution is happening. People can either embrace it or they can ignore it. Or they can go against it. If you go against it or ignore it, it's like a tsunami, it's still gonna wipe you out. So you might as well help shaping it. So that's enough of me talking about the DeepFake. So what DeepFake is, it's an AI methodology that can enable each and every one of you and each and every one with a computer to download a piece of software that enable you to put someone speaking in video, let's say, Barack Obama. You make him say some things that he didn't actually say. And he would look as real as Barack Obama. Now, that is AI methodology that keeps getting better and better every day. And it presented itself as a method to enhance people's lives. Hey, you can put this for a movie or somebody's absent cannot do certain things, but it could be used maliciously. So if you imagine, you see a video of Donald Trump saying, hey, we're declaring, we're launching our missiles against North Korea. And a lot of people don't believe it, but even if 1% of people believe it, it can be extremely dangerous. So a lot of Department of Defense around the world, they started working on solving this problem. One of the hackathons that we were working with in San Francisco, in Palo Alto, it was actually in San Mateo, which is close to Palo Alto. Two folks that they work for a consultancy firm that does work for the Department of Defense, they came to the hackathon and they said they're trying to combat deepfake. So if a video were to come out saying that this is Donald Trump, folks would know that this is fake and not the real one. In order to combat that, apparently, I did not confirm that according to what they have said to me, around $500 million in budgets in the last couple of years been put to combat deepfake. And all of that effort has been done using AI to combat AI. Now, one thing I gotta tell you that I've been doing AI all my life, and AI is probabilistic. The reason why I like cryptography as well is because cryptography is deterministic. One of my mentors, and he's also founding partner in my company, he's one of the top cryptographers out there, he says, cryptography and AI is like Romeo and Juliet. But sometimes they have love, sometimes they have hate. But cryptography can give you determinism. Is this really Donald Trump or is this not? You don't want to have a situation where you're not too sure, 90% accurate, 99.9. No, you cannot afford that. So, long story short, in that hackathon, which was about 48 hours, by the way, hackathons, how many of you have heard of hackathon, know what hackathon works? Okay, cool. Hackathon, it's like a marathon, but for coders. They sit together on Friday, they develop solutions, they present it on Sunday. So in 48 hours, they were able to build a solution that is deterministic in combating AI. That I'm going to walk you through this. So this isn't, I'm an invited speaker in a lot of events, but I'm also I'm a developer. I go to hackathons, so that's a little bit of full disclosure there, so I'm not just a talker. So there were two videos here, but they're not playing. So I'm going to tell you what those two videos I want to show you is. One is a senator who was assigned by the Department of Defense to lead that effort in the United States. I'm not sure there's an equivalent, somebody in Canada. And here was showing how the actual deepfake is working, where you literally stand in front of your camera and act it out and say certain things, and it looks like Barack Obama's doing it. And you can record that and post it out to the world. So, many of you, how many technical person here would know what hash function? Okay, for those that are not technical, hash function is something that would take any chunk of data. So for the computer, any data, whether it's a video or not a video or whatever it is, for the computer itself, is a bunch of zeros and ones and zeros and one. A cryptographic hash function takes any chunk of data. It could be an entire video, or it could be 1 minute of video, or picture, or whatnot, and it gives you something that looks like this, 32 characters. Now, in this 32 characters, to the computer is also zeros and ones. How many? 256. So, if you can imagine 256 combinations of zeros and ones, how many possibilities you could have? It's a big number. In reality, it's 160. You can have more atoms, more than the atoms estimated in the universe. So at 256, you can have like trillion universe representations. And the reason why I'm telling you this is because every single hash function is going to give you almost unique, with like 99.99999%, certainty that this is going to be unique. So the solution that it was built takes every minute of video. So let's say Donald Trump is making a video, and he can cryptographically sign it, and not to say that he has to do some effort. The software does it all on its own. Every minute it chunks it, it puts a hash, and someone else could be putting a video or transaction, and that's called temporal coupling. So that's during a block of time. This specific minute at, let's say, 10:20 a.m. Pacific time. That video that was taken, it does temporal coupling with someone else doing something else at this specific time, and gets hashed, combined, inserted into something that we call blockchain. And next minute it gets chained with another, the root of that. So one hash goes here, another hash goes there. The hash of both hashes gets to be hash. Same thing here. That happens once every minute. Effectively, every device on the planet gets only the top. But that is good enough to give you certainty that that video was signed by Donald Trump in that specific minute, and no one else can fake that. The ECDSA, it's a cryptographic signature. No one can fake that. So it gives a lot of elements of reassurance. Why is this so important for the audience here? When you see use cases of utilizing a blockchain that can actually work, that each and every transaction that is happening here in that blockchain, if you use Ethereum today, it will not work, like I said earlier. Why? Because the cost of running on Ethereum today is higher than that value of that transaction altogether, and it doesn't scale to all the videos. But the next, what they call the next wave of blockchains, I call it the tsunami, not a wave, is capable of enabling this kind of thing, to have all the videos in the world put together. Why? So imagine on this level, you have 1 trillion videos. What does that mean? How many levels it goes up? So every 2 they become 1, 2, 1, 1, 1, 1, 1. That's how binary trees work. That's 40 levels. Literally, just 40 steps. Any computer is capable of doing 40 steps in 1 minute. And that is powerful. So So that's one use case. The next use case here that I'm going to talk about is, many of you have heard of cryptoeconomics. How many haven't heard of cryptoeconomics? Raise a hand. Alright, so cryptoeconomics is basically using cryptography to ensure that something did happen, and using economics to incentivize the happening of it every single time to get it to work towards profit. The economy, that's how the economy works. You know, you wouldn't want to use something to spend, then you end up losing. When you spend, you don't get a return. But if you spend a little bit, you get more return, then the system continues to evolve progressively. So that's referred to as cryptoeconomics. So how would that work for something like the HBGA? Before I get to tell you what, I need to tell you what's HBGA. So GA is genetic algorithm. It's a methodology that's been invented about 40 years ago, but evolved over the years. John Holland introduced genetic algorithm in the 60s, and certain evolutions of genetic algorithms enable a lot of the things that you use today in your machine. So when you see certain thing that works in a certain way, or they call it artificial intelligence or an algorithm, many of those are actually utilized. They give you certain accuracy, but there's something much cooler that is actually happening. And it's called a human-based genetic algorithm, and that's in machine learning. It uses a methodology that the human is a component that the machine is learning as the human uses the machine. So how many of you have used Google Maps? Alright, so when you use Google Maps, it's using you as well. So the way it's using you, if it gives you an estimate that it's going to be 40 minutes, but then you take a shortcut because you know better. If you're wrong, it ignores you. But if it turns out to be 35 minutes, it learns from you and it applies it to the next person. Now, one case may not necessarily learn, but if repeatedly people do it, then it ends up learning. So it uses something similar to this. Well, the actual machine is getting implicit feedback. You don't have to give it feedback. It takes the implicit feedback and it learns from the people. Now, with Crypto-HBGA, the people, they're not necessarily implicit. The feedback can be coming in money. So when you have certain amount of money for somebody to give the right feedback, they are likely to give you the right feedback. If each and every transaction in teaching that machine, the person is gaining more money, it's likely that that person is going to give the machine the best of their knowledge. Otherwise, they're going to lose money, and that's what we refer to as cryptoeconomics. And Crypto-HBGA, HBGA is that algorithm in using crypto to power it. Now, this use case is also being used by one of the companies that I'm heavily involved in, and it's called MindOT. And the way it's used is to build an executive assistant tool that eventually becomes your executive assistant. So that executive assistant tool starts helping every executive assistant to do certain tasks. So let's say sorting messages. When I start talking here, I said I have one of my problems, which many of you may share this problem. You get 5,000 messages addressed to me per day. It's impossible for me to sort through those. I used to give it to my executive assistant, and she threatened she would quit. So, how do we solve this? Imagine a machine sorting through my messages. Now, sure, many people might think of adaptive learning and evolutionary computation that can actually learn on its own. But what if there are about 100,000 executive assistants in the world that they want to use that software, or maybe a million, whatnot. And each and every one of them, as they use it, they also train it. And they have the incentive to train it. Because as they're training it, it gets better, and as it gets better, they could make some money from it. So it goes to that cycle of Crypto-HBGA. How are we doing on time? Okay, level 10. How many? Oh wow, two, okay. Yeah, all right. So, so that's the next use case. The last use case that I wanted to cover, we didn't go through the details of this, but it's basically the processor remains to be a computer. The human innovator is a human, and it gets incentivized by money. And the human validator gets incentivized by money. Now, if you use the existing blockchain for that smart contract to process, it will not work. Why? Because A, it doesn't scale for a lot of people. B, the actual action itself might be worth a penny, but the smart contract execution cost to humanity about $2. Again, like I said, the next wave or tsunami of blockchains can enable this. I won't geek it out, but whoever's interested in geeking it out, tell you how that ontology is being built using decentralized governance. And decentralized governance meaning there isn't a single entity in control of the system. Why is that so important and revolutionary? Not because we're wiping out the government, hey, you know, screw it up, let's move them out of the way. It's again because of efficiencies. So every time you introduce a third party that you have to trust to manage that thing of value, they have to rely on certain methodologies to ensure that their administrators are not cheating. And that methodology could be called an audit, and then an audit on an audit, and then regulatory compliance, and then policy and procedure, and so on and so forth. And then they have to comply with regulators. That can be extremely costly, time and money. If the machine can do that automatically, that is called a blockchain, that is costing even more money, it doesn't make any sense. But when the machine can do it with a lot less money, we call that revolutionary. So the last thing before I get to it, there's something in nature. I use that in almost every presentation that I speak, and every time I speak on a different topic. This is a protocol called the alveolus capillary protocol. That right now in your lungs, as you hear the words from my mouth to your ears, there's a trillion of those exchanges happening per second. The oxygen and carbon dioxide, and it happens in a decentralized setting. Your brain cannot control it, it doesn't check with your brain, it doesn't ask for permission, it works flawlessly. Well, almost flawlessly, because some people die. But in general, it works flawlessly. So, so the last topic that I probably have only 1 minute to cover, which is the invading privacy in the name of security, it can be avoided to a certain extent, not to a full extent. And this is my recommendation to the Interpol, that they've taken into consideration and included it in the report that they released yesterday at the United Nations. So currently, if you're trying to chase or track a criminal, one of the methods that they do, let's say the triangulation, that method end up getting the data from all of those people. So if you're an innocent person here, they're getting your data, and that administrator might use your data for something else, or that administrator might use that authorization to get the data for something else some other time. But in certain methodology using network packet tracing with the value that is attached to the packet, they will only get the intersection, which is reduced drastically. So they won't have to invade everybody's privacy. It's only the ones that they really have a reason to do that. And I've included people like Jeff Bezos here because apparently his privacy has been invaded. So, I guess we share his pain. So what's the best way, if you were to ask, the most efficient and effective way to kill cancer? You kill the host. You kill the person completely. And that's why it's not acceptable to have invasion of privacy that takes liberty away in the name of security. So there are ways to do this. Interpol, finally, they're reacting. They took my recommendations, so I will not go through the details. My time is up. I just want to say thank you so much for listening. Any questions or whatnot, I'll be around here. Thank you.
Thank you, Toufi. Always going against the grain, providing insightful information. Okay, so we are very lucky to have our next keynote speaker, who is one of Israel's leading high-tech venture capitalists, John Medved, CEO of Our Crowd, a global equity crowdfunding platform that has reached $1 billion in commitments in 6 years. So,